start paper session 4A. And the first presenter is Mike Snell from Adler, and the title is Destination Solar System Now Boarding. We have, I'll give you 2 warnings, and then you can check if there are other questions or it's 10.
Cool. All right, well, good afternoon, everybody. My name is Mike Snell with the Adler Planetarium, and here today to talk about Destination Solar System, which is our new full dome feature sky show, which we opened earlier this year, back in May. Just a quick refresher for some of you that may not have been to the Adler in a while. Back in 2011, we renovated the historic Sky Theater, took out the Zeiss in the center of the room, put in a 20 projector 8K array. We lowered the dome down so it actually comes down when you're seated. The dome actually comes down below your line of sight, which is really nice for its immersive properties. And since reopening, we've been producing just about one feature show every year. So starting on the left, 2011, we reopened the theater with the sci-fi show The Searcher, sci-fi show but driven by actual scientific visualizations. 2012, we opened Welcome to the Universe, which is a Uniview-powered flight through our celestial neighborhood. And then 2013, we launched the Worldwide Telescope-powered show, Cosmic Wonder, which some of you may have heard me talk about at GLPA last year. So during this time, back in 2012, we started kicking around the idea to do a solar system show, because everybody does a solar system show. You have kids, you have school standards. It's a very popular topic matter, but we wanted to come up with a way to not only do it, but do it well. And one of the things we really strive to do is, of course, be scientifically accurate with all our visualizations, with all our content. So we started off by looking around at what sort of visualizations we could create and also what sort of things we could work with partners on. And we'll talk about some of our partnerships here first. So this is a simulation of a molecular cloud and a solar system, a protoplanetary disk formation. This was produced by Alexei Kritsuk and Aaron Bali, UCSD and the University of Florida. The National Center for Supercomputing Applications folks in Champaign-Urbana also helped with this a little bit. So flying in through the molecular cloud, and again at the center as we're getting closer, we can see it's a, I think it's a 13,000 or a 16,000 year simulation shrunk down into about a minute and a half in the course of the actual show. So we're doing, we'll do a lot of little snippets of things, and we've sped some things up just to fit everything into our delightful 10-minute window today. So we have the origins of the solar system, really fantastic, beautiful. It doesn't look too bad here. It looks great in 8K on a 70-foot dome. Definitely stop by and check it out if you're ever in the Chicago area. So we have the early solar system, the early formation. You can see the protoplanetary objects starting to clump together there. But then we also, of course, want to talk a little bit about the current solar system we know now. So we created, NCSA also helped us do some solar surface work, and we worked with the National Center for Atmospheric Research on these sunspot simulations. So you can see them in the front of the dome here. And then if you look carefully, they blur a little bit, but you can also see some really nice loops and prominences around the horizon of the sun as well. So we also, when you're producing for any highly intensive graphic format, whether it's 4K, whether it's 8K, whether it's stereo, there's a lot of work that goes into that. So we're also, of course, working under timelines, looking for ways to shorten the production process and work faster, work smarter, not harder. So we took advantage of SCIS Uniview, and we used that to actually do a lot of previs work. So various imagery to set up our flight around the solar system, to set up the various shots. We can use the moon, we can use Mars. We were also able to transpose, to take those previs. So here we're flying into Titan, and we were then able to match them up with the simulations that we worked on. So this Titan, it's really nice. So we're passing down through the clouds, through the atmosphere of Titan, and then down just over Ligeia Mare. And we worked a little bit on this one with the folks at Paris Diderot Space Camp. A little IO visualization that Patrick McPike and the folks at the Lunar Planetary Science Institute worked on. Mark Subarow as well at the Adler. Those two both headed up the production process. So a lot of work. We did a really nice Jupiter Great Red Spot viz, and then a Jupiter Aurora shot, a nighttime shadowed Aurora shot. Here's Patrick just doing some of the comp work on that. Also, one of our other partners on the show was XRES. A lot of people know XRES. They did some graphic overlays, and they helped work with this like highly sped up launch off of the surface of the Earth. Nope. Hang on, did we? That ended a little quicker than I thought it was going to. All right. So by this point, we had a nice start. We had a lot of images, we had a lot of scenes, a lot of high points in the solar system, really solid ways to visually immerse our audience in the content, but we were having a little bit of trouble gelling around an actual script, an actual way to tie it all together in a sensible, educational, informative, not too overwhelming way. So we ended up falling back on some old friends. We have producer Christina Del Fico and then director Ken Diego, who we both worked with on the One World, One Sky, the Sesame Street show. And then also not pictured here, Karen Greenberg, who writes for them. She writes for La La Loopsy and lots of other kids shows. She wrote the script treatment for what would become Destination Solar System. And it was an interesting script treatment because it was a tour of the solar system in the not too distant future, the year 2096, when space tourism is all the rage. And there is a company known as Space Express Tours, which takes people all around the solar system using their patented space jump technology in 30 minutes or less. Planets, asteroids, moons, all sorts of fun locations. So this got us thinking, 2096, you of course have that, what's the world like? So we have brainstorming meetings about what are things like in the year 2096. 2096, have the Cubs won another World Series? 2096, is it illegal to put ketchup on your hot dog in the city limits of Chicago? The answers are no and yes, in case you're wondering. In the not too distant future, has the Earth run out of resources and citizen science has launched into space to save our planet? No, this is Interstellar, the new Christopher Nolan film. Chris, if you're watching, please don't sue us. I really like your work. So to carry the show, we had a character. The character is known as Jesse, and Jesse is the tour guide, leading the show, leading the tour around our solar system. He's young. It's Jesse's first day on the job, heading out with our audience into space. And to play the role of Jesse, we hired a crew of local, talented Chicago actors, folks from Second City and Goodman and all over the place. And of course, that's always the question, is it easier to hire actors and train them to science, or is it easier to hire scientists and train them the presentation skills?
Ain't happening. Personally, not actors.
So we've gone both ways. We've actually had a lot of success doing both at the Adler. But for this show, with it being so themed, with it being set in the future, there's costumes, there's backstories, there's set pieces. We chose the actor route. We, of course, have a fantastic astronomy department, so the entire team went through training on solar system objects so they would not be stumped by audience questions at the close of the show. And again, we mentioned a little bit of some of the theming, just some of the early art. It was very heavily costumed. Again, really, we want to put our audiences in the experience. We want to put them in the year 2096. We want them to believe they're traveling through the solar system. So some early sketches of the sort of Jesse uniform. This also gave us some flexibility to theme our lobby area. We call it the Welcome Gallery. So we use video projections, screens, audio announcements to simulate a sort of spaceport environment, a futuristic airplane terminal, if you will. So various announcements in various languages about, don't leave your bags, showboard or gate, flight boarding at gate A3 in 5 minutes, things like that, to again really extend the performance, extend the presentation out of the theater, and really make it part of the greater museum experience. So that's really how it all came together. We had the scientifically accurate, the beautiful 8K visualizations on the dome. We have a fantastic story, an educational story about traveling around our solar system, visiting planets, moons, asteroids, the sun. And then we had a fantastic crew of actors to make it real, to bring it to life, to immerse our audiences in the visualizations, but again, also educate, entertain them along the way. So I know I'm way under on time, so we'll open up for questions. If you want to get in touch, you can find me on the internets. I'll also be around today and through the rest of the conference tomorrow.
We've got about 2.5 minutes for questions.
All right, 2.5 minutes. So does anybody have any questions about Destination Solar System or the world of 2096 or things like that?
So when are the Cubs going to win?
Well, we just ran our simulation out to 2096. You know, if we'd gone out another couple hundred years, it might have. They're finally renovating the stadium, though, so who knows? We'll see what happens.
Maybe they'll do it.
They just needed that jumbotron. That was the one. Oh, all right.
How's the ice working out?
Chuck.
So how many actors do you have to hire in order to meet your schedule?
So we hired a crew of 6. The idea, initially we hired 4 actors and then we hired 2 understudies. And we ended up being a good thing because then again, some of them have other jobs, they have other gigs, and they tend to have very, very sporadic schedules. You know, they're not available in evenings, not available weekends. So we have a crew of 6. We had a couple of them leave our crew. We just hired 3 new Jessies this past week. So that has been the crew. And this show takes place 3 or 4 times a day. So we usually just schedule 1 for a day. They do all the shows. And that's par for the course for most of our show operators. They'll do 3 to 4 live shows a day, and then 3 or 4 playback pre-rendered shows as well.
Thank you.
Yep. Okay.
Do you have any evidence that the visitors buy into this scenario?
So yes and no. Some do, some don't. You know, of course, it's 2096. Not to give away the finale of the show, but we have a close encounter with the rings of Saturn, and the Jessie leaves the ship. Basically makes some repairs, comes back in with a glass ice chunk that simulates a chunk of ice from Saturn's rings. And we've definitely had people that have come up to the desk after the show and been like, how do we do that? Like some really, like adult, grown visitors. Just that really bought into it. Kids, of course, eat it up. The show does skew a little bit younger, but elementary and middle school audiences absolutely love it as well.
Do you have curriculum standards?
We do not. So the show was created we didn't produce a teacher's guide with it. Right now we're weighing obviously like distribution possibilities and options. And if we do put the show up for distribution, do we package it the same way? Because again, not a lot of folks have, like some folks might be willing to hire actors, some currently have actors, some want nothing to do with that, all of which we understand and respect. Some, so we're kind of looking at options. Would it make sense? What kind of distribution version of the show would make sense? And once we get a little further down that road, we'll probably look at we'd make a full package to go along with it.
Cool.
So, cool. Thanks so much.
About 3:15, so maybe I should just go ahead and get started.
You're right on ahead.
All right, well, good afternoon. Thank you for coming to listen to my talk. I'm going to talk a little bit about something called the MC Squared Science Collaborative that we've been running at Marietta College. And I spoke about this 3 years ago, so some of you may have heard that talk, but I'll remind you what was going on then and then tell you about what's been going on since then. All right, so first of all, for those of you who do not know where Marietta, Ohio is located, we are in southwest Ohio. We are a fairly small city of 15,000 people. We are the county seat of Washington County, the first organized settlement in the Northwest Territory. So we have some Revolutionary War soldiers and so on buried in our cemeteries who moved to Marietta after the war. Our college has about 1,300 students. We're a liberal arts school. We also have some engineering programs, education programs, and so on. All right, so our planetarium, which you can see in some of these pictures, was opened in May 2009. And the reason that we have this planetarium is thanks to the generosity of an alumnus who graduated from the college in 1978. That is Dave Rickey, who donated over $3 million for the construction of this planetarium. So yeah, we're very, very lucky. So we have a 40-foot dome and a Kronos Digistar 3 hybrid, which you can see a little bit there in the picture on the upper left. And you can see a little bit from the construction there on the lower left, and a couple exterior photos, and part of our lobby there on the upper right. So in the 5.5 years roughly that we've been open, we've had about 43,000 visitors, which is pretty good given the size of our community and that we live in a fairly non-populous part of the state. About half of those visitors have come through school groups of all ages. About a third have come through public shows, which we hold monthly, and then we've had assorted visitors through camps and churches, civics groups, things for the college like homecoming and so on, where we've done programming. All right, so we opened in 2009, And the MC Squared Science Collaborative kind of has its roots in that first year after the planetarium opened, the 2009-2010 school year. And what happened during that year was one of the geology professors who'd been doing some outreach to elementary schools, along with one of the elementary school teachers who'd been routinely bringing her classes for geology outreach, approached me about putting together something that would hit all of the earth and space science standards for all of the elementary school grades in the district. So we spent that year planning how we were going to do this. And so we eventually decided that the kindergarten, second, and fifth graders would all come to the planetarium because those were the grades that had astronomy-related standards at that point. And then the first, third, and fourth graders would all have geology activities. And so the man in the picture up there is my colleague Dave Jeffrey from the geology department who does the geology programming. And the picture that you're seeing up there was from a news story that was on our website the first year that the collaborative actually happened, which was the 2010-2011 school year. So we had pretty good participation. We have 4 elementary schools in the district. Sort of 2.5 of them are walking distance, by which I mean one of them, it's a little far for the little kids, but the older kids can make the walk. So only one of the schools needed buses for all of their visits. And we were able to get close to 100% participation of the classes at the different schools. Part of how we did that is that there was some grant money that paid a building coordinator at each school who encouraged the teachers at their school to come and participate in the program. All right, so what I wanted to mostly talk about today, though, are the things that are new to this program, because everything I just mentioned was in my previous talk. So we've made some additions to the program and some changes, but we're still going with all of this. So the first big change is that we've added some new sciences, a little at a time. So in the 11-12 year, we added chemistry. And that picture on the lower left is one of my colleagues from the chemistry department, Kevin Pate, doing a chemistry demonstration with a student. And then we added biology in 2012-13. We didn't add anybody new in the last couple school years, so I'm not sure that that's going to happen anytime soon, but we're now getting some of the physical science standards and some of the life science standards, and not just the earth and space science as we started out. So some of these visits involve the students coming to the college. Some of them involve the faculty going out to the schools. So in chemistry, they do a little bit of both. The kids come and they have a chemistry magic show that has lots of explosions. I've been teaching labs in classrooms across the hall from where this is going on, and it's very exciting when the kids start screaming over there, but it seems to be very popular. And then he goes out to the schools and does some little experiments with the kids later on as a follow-up to their visit. All right, so adding these sciences has definitely enhanced things a little bit. These are the grades that do each activity at this point. So for astronomy now, it's just the kindergarten and 5th grade. Part of that is because of changes to the standards, which I'll mention a little bit later, but the 2nd grade had all the astronomy standards taken out. But we also split it up this way so that we would each be dealing with 2 grades, and it kind of spread things out evenly between the different faculty members who are involved in the program. Another thing that was added in the 11-12 school year is Meet a Scientist Day. And this happens in May of the school year, and all of the 5th graders in the district come to campus on the same day. And this generally takes place between the end of our school year but before graduation. So campus is still sort of up and running, but it's a little emptier because most of the students have gone home. And the idea is to give these 5th graders an experience on a college campus. They get campus tours. They eat lunch in the cafeteria. They love the fact that there's pizza there and ice cream and all the things that 5th graders love to eat. But then they also do 30-minute sessions with a variety of different scientists on campus, some of whom are the scientists involved in the collaboration throughout the year, but then some additional scientists as well. The students are broken into small groups of about 10 or 12, and then some of the activities, multiple groups might be combined. So when they come to the planetarium, I'll have 2 or 3 of those groups at once and end up seeing all the kids over the course of the day. Some of the other places, they need fewer students. So, for example, this is our greenhouse that's on the roof of our science building. And so this is a biology professor at our college, Dave Brown, and you can't bring too many kids up there at once because it's kind of tight. So that was the sort of thing where only one group would be up there. Here we have a professor in our engineering department doing some activities with kids, and one of our anatomy professors who now teaches in the physician's assistant program doing some activities with kids. So got a lot of participation from across campus, and we were asked in our sessions not just to talk about science, but to also give the kids an idea of our career paths and how we got into what we're doing to get them starting to think about their own careers and what they might do in the future. So it's kind of interesting having all the fifth graders come to the planetarium because they had all come to the planetarium earlier in the year. So fortunately, they came in the winter. So when they were coming then in May for this Meet a Scientist Day, the sky had changed a lot. And so I could show them some different things that we hadn't seen before. And I used the time while the lights were dimming to tell them a little bit about how I got interested in astronomy. So it worked out pretty nicely. Oh, and as you can see, we got written up in our local newspaper, the Marietta Times, and they had photos and everything. It's very nice. We've also had annual professional development days, in July, where we've had the elementary school teachers come to campus, and we've talked to them about the programming and gotten their feedback. And that has been very valuable because so often a school group will come, you'll do a program for the class, and you'll never really hear anything about how well that worked for the teacher, if it was what they were expecting, if there were things that you did that confused their students. So it's been really helpful to have a chance to talk to these teachers every year and find out what is or isn't working in those programs. And I have made some changes in response to some of this. I was not available to attend their professional development day in 2013 because it happened to fall in the middle of my honeymoon. I had just gotten married that summer. But I was able to arrange for a volunteer to show them the Cosmic Colors show, a GLPA program. And then they wanted to have that included in their fifth grade program because they do some stuff with light. They don't get into the wave nature of light, but they do enough with light that they thought that meshed really well with what they were doing. So again, that was by their request after they had a chance to see the show. All right, so the one other thing, don't want to talk about this for too long because I think I'm...
We've got about 2.5 minutes.
Okay. All right, so let me just say this really fast because there's a ton of words up here and you can read them in the proceedings. But one thing that has happened since 2011 is that the standards have changed, which has required changing what programs we're doing. And so the astronomy, it all moved out of second grade. It's all in kindergarten and fifth. So I'm seeing them at the opposite ends of the spectrum there. I know that you will not be able to read all these words right now, but I just felt compelled to stick them in there. So I have here all these standards, but this is also in my paper, so you can see them there as well. And the fifth graders have so many standards, I've split their stuff up into two different programs, and sometimes they'll come twice if they're one of the walking distance schools, and if they're the driving distance school, we'll just do a really long program with a break in the middle so that they can get everything at once. All right, so on the whole, I just wanted to offer a couple closing thoughts. I think that this program has been working really well. It certainly made me more aware of the standards than I would be otherwise, because the programming I was doing before this, I never paid too much attention to the standards beyond what a teacher might tell me they were covering in class and trying to hit those things. And that has, I think, influenced the programs I do for groups from other schools that aren't part of our district. So even though this is specifically focused on our school district, it has certainly, I think, enhanced the programming that we're offering to other schools as well. What I would like to see us do is move into the middle school age range. The middle school lives just right up the hill from the college. It would be very easy for them to come, but it's very difficult to get them to come for some reason. So perhaps we will start to add that in soon. All right, so I think I'll stop there and
You've got another.
got it.
There's a couple questions. You got
All right.
30 seconds.
All right. Anybody have a really quick question? Yes.
How do you get the teachers to come to you in July?
Oh, how do we get the teachers to come to us in July? I believe that they are required to do a certain amount of professional development to keep their jobs, and so this is something that can count, and so that motivates them to come.
Okay, and also the other question is, do you know why the standards were taken out for the seventh grade?
I think the idea with the new standards is to make them deeper, but not cover as many topics with the different grades. And so because of that, I think they are trying to have fewer sort of big topics with each grade.
What do they have instead?
I honestly don't know. I haven't looked that closely at the non-space science standards.
Thank you, Ann.
Hello. Okay. Next up is Sherry Adams from Boonshoft in Dayton, Ohio.
Thanks, Deb. As Deb mentioned, I'm from Dayton. I'm with the Boonshoft Museum of Discovery. And there at the Boonshoft, some of you had an opportunity to come to see us back in 1993 when we hosted the GLPA conference. And not much had changed from the astronomy wing when our president and CEO arrived in 2000. And so he said, why don't you give us some plans of how you can update your astronomy wing? It was a hallway surrounding the planetarium. And we said, sure. So we put up some plans together of how we'd like to renovate that hall and submitted them. And the next year he came back and he said, why don't you submit some plans to us? And I said, sure, great. We'll do that again. So this went on every year for the next 7 years. And in 2007, he said, no, really, we're going to really upgrade the astronomy wing. And so he very formally had us present to our board of trustees. We are a 501c3 nonprofit private organization, and we're run by this board of trustees. And so we went formally before them and submitted our proposal. And we went along with not only are we an Aztec and a children's museum, but we also have an accredited AZA facility. So the zoo folks also went before the board, and they loved our proposals. They said, great, we'll support a capital campaign in order to have this renovation done in both of your departments. So then the bottom fell out of the economy. And so ethically, they thought it was more important to take care of the animals, which they did. And so that left the astronomy department to try and figure out what they would be able to do, because really the animals are cool that we do have there. So our president and CEO came to us and he said, okay, now you need to apply for some grants. Well, the only grants that I had been involved in applying for were previously philanthropic foundations that were in the local community. And so they were for relatively small amounts, like $30,000 or $50,000. And so this was going to cost a lot to do a complete renovation for the hall. So he said, go before NASA. They have this competitive program for space or for science museums and planetariums that used to be called CP4 SMP. Now it's got a VC on the end of it because it also includes their visitor centers. And he also said, go before the Institute for Museum and Library Sciences Services. And so we did that, and we didn't get any money from NASA, but we got $150,000 matching grant from IMLS. So we started instituting that, and our president and CEO said, go back the next year and try and apply for the NASA grant again. So what we did was we really were clueless about what they were looking for the first time. Those of you that have facilities that are very formally involved in regularly getting funding, you have a rhythm and you have very organized folks who do this, but we just had never been in that position before. So we thought the best thing to do was to learn from that experience. So what we did was we very carefully paid attention to what the reviewers of our grant said about our grant proposal, and we really took it to heart what they suggested that we do or not do. And then also we paid attention to what places did get awarded their funding for their requests. So we got a much better understanding of what they were looking for. So what we did was we went ahead and we decided we would align ourselves with a NASA mission, the Kepler mission, that was just going up in March of 2009. And so we looked for collaboration with some of the scientists at Kepler, at Ames, a couple of the co-investigators that were involved in outreach education. They were very willing to assist us in doing some planning. And so we moved forward with that, and we proposed that. So we heard back from NASA, and when they were deciding on their 2009 proposals, and they said, you're not going to get a 2009 a grant, but we have a few questions for you to answer, and if those are acceptable answers, then we'll probably fund you in 2010, and so that's what they did. So in 2010, we got an award for $818,000 from NASA to do a variety of implementation that were very associated with NASA. So basically what we did was exoplanets was a really new topic, and to this day, most of our visitors who walk in the front door have not been introduced to that topic before. So we wanted to introduce the topic of exoplanets, and we wanted to assist them in understanding how in the world do you detect something that you can't see. So we went through the different methods of how that was, how they were being detected. And of course, STEM is really the rage. So we wanted to involve STEM education in every avenue that we possibly could. We wanted to enhance the visitors' knowledge and understanding of what missions were involved with NASA. It wasn't just Kepler, but a lot of associated instruments, Chandra and Spitzer, are all involved in many different venues, one of which is exploring for exoplanets. And we wanted to give them kind of a basis of how do you figure out some of this stuff. In particular, we did a lot of work with the electromagnetic spectrum and tied that in because of all the different wavelengths that are involved. So it was a very long process. We did have the opportunity that we wrote into the grant to collaborate with folks from out in California in particular. So we were able to visit about 12 different facilities out there and develop relationships with these folks. And we got wonderful supporting feedback from these folks. We went to Kepler and they said, oh, we love the idea of promoting Kepler and doing all kinds of really wonderful things. And then we went to JPL and they said, you know what? That's really great, but make sure that you understand that Kepler is a very defined mission, and that if something happens to the mission, that you don't want to outdate yourself. So make sure that you are more broadly spread among the other missions. And we took that to heart. We thought that was very good advice, which we were very happy that we did so, because as you heard, some of the folks had previously commented about how the wheels, that it requires 3 in order for Kepler to point its instrument in the right direction, and 2 of those original 4 are non-functioning. So we did all this work, and we opened this past Thursday, October 23rd, and it was associated with it was a Dayton Science Festival. Those of you that heard April Witt's Science Festival, we've been doing this for several years, but we're on a much smaller scale. Dayton is a smaller community, but we didn't have as much involvement. But every year it gets a little bit bigger. So we had several hundred students come into the building, and which was really cool because those of you that remember, October 23rd was also the date of our partial solar eclipse. So it was really cool to be able to bring all of those students into the planetarium as well as going out into the exoplanet exhibit. And they got an opportunity for us to talk to them about the solar eclipse that was getting to happen and how that's kind of like a transit. And so it was a great transition for us to explain a little bit about what that was going on and how it transpired out into the to the exhibit hall. So for the last several years, I've been providing a poster about our exhibit where it was just drawings of the exhibit, and now I actually am so excited to be able to provide you with actual photographs of our exhibit, that it's truly open. So there's a lot of things that we didn't anticipate, which I'm sure many of you have been in the same boat, where you think of as many things as you can ahead of time to anticipate what could or could not go wrong. And so there were a few surprises, one of which that we haven't had this instance yet, but The logo for the exoplanets exhibit has this really cool ring showing the orbit of a planet in orbit around that star. And it is a ball that's coolly painted as a planet, and it's protruding out from the wall. So we're just waiting for the kids to run by and whack it, as they jump up. But nobody did that on Thursday, which we were quite pleased that we made it through the first day. But basically, we have an intro wall here that just explains what an exoplanet is and some really cool graphics. Jason Heaton, I'm sorry he's not here. He was not able to come to the conference this time. But he just did some phenomenal work, as well as Joe Childers that I work with. And so we have some really cool graphics in a lot of the stations. The old astronomy wing was built back in 1991, and in those days we still went to museums and read text, and there wasn't anything else, but you just read text and you just didn't think about doing anything else. Now, of course, our visitors are much more influenced by other experiences that they have, and they're looking for interactive. So there are 12 different stations where there are very physical interactive opportunities for them. The first station that was just around the corner from the intro was about, it's with the video of PhD Comics. I'm not sure if you're familiar with that, but it is a really cool opportunity to bring in just it's a very brief description of how methods are used to detect exoplanets, and it's in a cartoony kind of a sketching, and it's very fast-paced. So that's a great station that we have there. Thank you. The next station is a lot about what the Kepler does, and that we have a light source representing a star. We have a light detector here. What's displayed up on the dome or on the screen there is that the visitor comes by and moves these planets that are of various sizes, and they transit across the light of the star. And so that's a really cool way of immediately demonstrating and seeing the drop in the light curve that you see on the screen there. Just down from there, what you're not seeing in here was the transit hunt is an activity that you can actually go online and see on the Kepler website. But that's a station that we anticipate that some folks will be interested in doing that. The station right here displays the radial velocity. There's just a great demo where you spin just a ball, and it demonstrates a star without a planet in orbit around it. And then these other two stars have planets that are protruding off the sides of it. One's low mass, one's high mass. And so you can distinctly see, as they are stationed on springs, about how the wobble occurs. So we explain what the radial velocity method is, about the center of mass. And then over here, Planet Families picks up on that, where you just draw in different planets, multiple stars. And the goal is to establish a stable solar system, when in fact it's way more fun to establish an unstable solar system. And so you drag in all kinds of comets and asteroids, and you get things wobbling around, and it's way cool. Planets get ejected out and get gobbled up, and it's really a lot of fun. And then the station down here is about the habitable zone, which of course Kepler is looking for Earth-like planets in orbit around sun-like stars located in the habitable zone. So this is just from the other angle. The two most visited stations so far have been the Planet Families, where you establish the stable solar system, and the infrared camera that's up here. And it catches your eye as you walk around the corner, and you see your motion moving across, and the infrared camera displays your image there right next to your visible image. And so, okay. All right, so, and then this is a string vibrator. So a lot of this is just talking about the electromagnetic spectrum. This is an overall view from one direction. There's an overall view from another direction, a little bit about the telescopes. We now have view space. And so anyway, so this is our exoplanet exploration exhibit. So we're really excited that it's here. So, and thank you. And if anybody had an opportunity to see Mark Reed's presentation earlier, he had lots of really good suggestions if you're wondering about the application of applying for different grants and what kind of procedures you should go through. Questions? Thank you.
Okay, next up is Gary Lacey from Illinois. Elk Grove, Illinois.
Elder Planetarium.
Elder Planetarium.
have a couple minutes. Okay, ready? Good afternoon. My name is Gary Lazich, and I will be speaking and showing about thinking outside the dome, the Adler Planetarium floor programs. A debate continues to rage on Dome L over optical mechanical projection versus full dome projection. Actually, planetariums have far more similarities than differences in that most convey information to a relatively passive audience. What happens to the information from there? How has it changed the audience members? Has it changed them at all? What do planetariums do to visitors? Alan Friedman moderated a panel discussion with this title at the 1980 IPS conference in Chicago. The results of the research conducted by his panelists suggest that, except under narrowly defined conditions, we really don't know. Today, nearly 35 years after that discussion, we still don't know. Jim Bieber reports, "I have yet to ever do or see a program that doesn't have an audible accompanying the stars appearing on the dome. A dome theater program often evokes this response. But where do we go from Can we go from sensationalism to science? How? How do we get our audience members to explore their world using science? By simply conveying facts? Carl Sagan asserted, science is more than a body of knowledge. It is a way of thinking. By teaching through discovery? Exploratorium founder Frank Oppenheimer noted, many people who talk about the discovery method of teaching are really talking about arranging a lesson or an experiment so that students discover what they are supposed to discover. That is not an exploration. To engage our visitors in science, we must use the constructivist approach developed by Jerome Bruner, in which learners are encouraged to discover facts and relationships for themselves. Knowledge must be constructed by each individual knower through the process of trying to make sense of new information in terms of what the individual already knows. Watch A Private Universe to see this in action. This requires a change in our role as planetarians. In the traditional model of education, the lecturer is the sage on the stage, the one who has the knowledge and transmits that knowledge to the students. In the constructivist model, the lecturer functions as a guide on the side, facilitating learning in less directive ways. In other words, our visitors learn science not by hearing about it or by watching it, but by doing it. How does all this apply to the planetarium? Like Jim Bieber, I believe truly that the best planetarium programs are those that actually get an audience involved. One way of doing this results in participatory-oriented shows pioneered by the Lawrence Hall of Science in Berkeley, California. Planetarians interested in this approach have been participating in live interactive planetarium symposiums like the one held this August in Mystic, Connecticut. How many of you participated in GLPA on Wednesday? You had an experience with it then. POPs and LIPs involve primarily smaller conventional planetariums. How have larger full dome facilities tried to incorporate the interactive approach? Some systems feature interactive keypads in their seats. Unfortunately, the system does not allow the presenter to pose open-ended questions. Lately, Adler Planetarium has taken a different approach to engaging its visitors in science. Rather than concentrate on interactive theater programs, it has developed interactive floor programs as a way to encourage thinking outside the dome. In 2012, taking their cues from Understanding by Design, the education team developed the first programs by first deciding on learning goals, then developing a rubric to test the achievement of those goals, and then finally developing the programs. During the past 2 years, the floor programs have expanded as Adler added part-time floor program facilitators like Krista and me. The programs have also evolved from demonstrations into mobile laboratories at which visitors can perform guided science experiments. Originally conceived of as a progression from knowing through understanding to demonstrating, or KUD, the programs now have a somewhat different rationale. The Public Programs Department at Adler Planetarium believes each informal educational experience should engage the visitor in wondering, observing, and discovering more about our universe. It should be one that involves the visitor in exploration that draws on their pre-existing knowledge and interests while relating back to the strengths and mission of the museum to inspire exploration and understanding of the universe. The program should incorporate museum connections and resources, appropriate methodologies, straightforward and obtainable learning objectives, knowledge of the audience, engagement and inquiry-based learning, and personalization and relevancy. The Adler Planetarium Handbook for Floor Program Facilitators advises, as a floor program volunteer, your goal is to reach and engage our guests. How do I do that? The process begins with hooks, or icebreakers, or invitations, questions that provoke interest based on the learning goals. How would you like to see invisible light? Would you like to launch a rocket to the moon? What happens to things in the vacuum of outer space? The process continues with open-ended questions and positive reinforcements for answers. Good floor programs involve the visitors in deciding on and performing activities under the guidance of a facilitator. Before each activity, I ask, what do you think will happen? Why? With no right or wrong answers. After each activity, I ask, what happened? Did you think it would? Why did it happen? How could we find out? Although our programs last only about 10 minutes, I encourage visitors to continue their explorations in related exhibit areas. Education staff members periodically evaluate our performance, making sure that we ask guests motivating questions, engage them in inquiry, engage them in activity, connect to science content, address misconceptions, and connect to the rest of the facility. When the process works as it should, the results are simply marvelous. One day I was facilitating the under pressure program with a vacuum chamber. I had previously blown up 2 balloons to the same size, had a visitor place one in the chamber, leaving the other outside as a control, and evacuated the chamber. What do you think happened? After I repressurized the chamber, asked my usual questions, and talked about equalization of pressure, one boy asked thoughtfully, what if it had been a helium balloon? Surprised and delighted, I drew on my training. That's an excellent question, I affirmed. I don't know the answer. What do you think would happen? Well, he replied, it would float because it's lighter than air. Yes, I countered, but what happens when we take the air out of the chamber? How could we find out? At that moment, I wished I'd had a helium tank so we could test his hypothesis. I hope this example illustrates how you can promote inquiry and discovery, whatever your venue, whether in conventional planetariums, digital ones, or in exhibit areas outside planetariums. We have ways of doing science with our visitors instead of just telling or showing them. One approach involves large facilities with immersive programs that kindle a sense of wonder. Another involves small facilities with interactive programs that kindle a sense of discovery. Need one exclude the other? Not at all. We can have the best of both worlds. The Adler Planetarium floor programs complement shows in its dome theaters, serving as a model for providing visitors with a more complete and satisfying blended experience. Few people knew about this blend more than Richard Feynman. He wrote in a footnote to his lectures, poets say science takes away from the beauty of the stars, mere globs of gas atoms. Nothing is mere. I too can see the stars on a desert night and feel them, but do I see less or more? The vastness of the heavens stretches my imagination. Stuck on this carousel, my little eye can catch 1,000,000-year-old light, a vast pattern of which I am a part. What is the pattern, or the meaning, the why? It does not do harm to the mystery to know a little about it. Thank you. Questions? Ask me.
How long have you had the program?
2011 did it start?
Oh gosh, I'm not positive.
It's been several years. It's relatively recent.
The weekday volunteer program started just over a year ago.
Right, but mission specialists were going before that.
Yeah.
And it has evolved over the several years we've done it. Jeannie?
I'm wondering what kind of evaluation process you're using, other than just your gut feeling to know that this works. But is there any interviews of the participants or anything that can be used for maybe grants or something to show
As often happens in large institutions, that's the education department. We're the interpretation department. But my paper will have references and contact information for people at the Adler so you can contact them about post-evaluation surveys. They apparently like what they see, and they like seeing the visitors interact with us. Yes, sir?
And you now are the education department, so.
Well, I'm representing them, yes. That's true. That's true. Education and interpretation do a lot of crossover that way. Special thanks go to Michael Sims, Public Programs Educator, for invaluable help in preparing this paper, and to Adler Planetarium for some of the images. Now, that was the show and tell with floor programs, but remember Confucius' proverb? I hear and I forget, I see and I remember, I do and I understand. In the next presentation, Krista Thompson will help you experience the do.
Hello? I've never used one of these before. It's really weird.
Use that if you want, the wobbler.
Oh, I think that would be even weirder. All right, so I was standing up here the whole time with these cool things, and I didn't really get a chance to show anyone what they do. Does anyone want to volunteer to come up and help me with this? Yeah? Come on. Okay, this is UV light. And all we have here is just a couple things. And these things are actually given to me to use today by Dana and Ron here at Ball State. And they have a couple of the same things that we have. So I want to just shine it on some of these things. And what happens? It glows?
Yeah.
Yeah?
Do that.
Okay. This is,
Shines
what color is that?
red and pinkish.
Pinkish? All right. What was it before we turned the lights off?
Orange.
Orange, yeah. Isn't that weird? Let's see. Right here we have some beads.
Stay clear.
They stay clear? Oh, wait. What?
After you take the light off, they turn colors.
After you take the light off, they turn colors? That's so weird. So, oh, and these. They same color?
Yes. Well, they glow and then they turn back to their color after light is removed.
Do both of them?
For both of them?
Just for one.
Just for one? Isn't that weird? Here. Try putting the sunglasses on the light. Still glow? Not as much, but they still glow? Try using this piece of glass between the light. Have you seen something like that before?
You can't see through it.
You can't see through it? What about under it?
It doesn't, no light goes through it. So
No light goes through it to the marbles. This is a welder's mask. They use this when they do like work on machines and stuff. Isn't that cool? Thank you for helping me out. Okay, where's the lights at?
Oh,
Right here,
right around the
this
corner.
side.
To your
Okay.
right. There you go.
Back step.
Oh,
Yep, there you go.
all right. So I don't have anything as prepared as anyone else did, but the more I thought about it, the more I was like, isn't that the point? We don't want a scripted experience with our visitors. Not everything we're going to be prepared to talk about. And I'm going straight to the question that you asked earlier about how do we evaluate, and that's a really good question because as of right now, we're working on it. right now, the only evaluation that we have is clicks.
No.
How many people have visited our carts, and that's about it. We have these little clickers. And if anyone comes up to us, even if they ask us something completely unrelated to what we're doing, we give it a count. Just one. We don't know how long they stayed there, and that would be really, really cool to find out. But what I'm talking about with what I'm going to be doing my research on, hopefully, soon, is whether or not these matter. Is it worth investing? I think I bought one of these for myself, $10 or so. Is it worth investing in these little props? Does it help improve the public's experience with us? And it also goes into like the multimodal approach. Does having all of this overstimulate? Does it help? Does it hurt? Should we have pictures in the background, which we normally do? Right now it's just Ball State, because I came completely prepared.
I can put up something if you want.
Oh, no, that's fine. That's the point, right? And a lot of research has been done on touch and its influence on whether or not it helps people remember things. And most of it that I've been able to find is in marketing. The more often a customer touches an object, more likely they're willing to buy it, that sort of thing. But how does it apply in education? And more importantly, how does it apply in informal education? And if anyone has any resources they can give me, that'd be amazing, because right now I just have marketing research. Oh, and a couple people from a couple different planetariums or museums, like Sue Ellen from the Exploratorium has said that the most popular of their exhibits have been the multimodal exhibits, ones that include text and touch and physical activity. So, the current, it's hard to, I did a lot of data collecting, counted manually each time. We did a cart for 4 months. Each day, counted each time an instance where the cart came up. It took a really long time. And I picked out 4 carts that I know my paper says 3, but I picked out 4 carts that I wanted to look at. And it's the ones that are very, very low hands-on. I would say that the balloon rockets that we do is very low touch. Even though we do have the child pinch the end of the balloon, we tape the balloon to a string and send it up to the moon, which is taped to the wall. Compared to UV, which has a ton of really, really cool little things we can play with. Usually, I am a lot more happy playing with these because then it gives me something to play with too. And I am just as excited about playing with these things and finding out new things as the kids are too, or the adults. Adults will come up and want to launch a balloon rocket. And I feel weird asking them to do that. But so many of them are like, yeah, I want to try. I was like, really? Okay. So it's really, really, really cool to see what people can surprise you with. And I've had like a 9-year-old boy run to his mom and grab his phone, his mom's phone, find a video of him at the Museum of Science and Industry, and have his shoes lit up on the plasma ball when he touched it. And so we actually that day, he came back with a friend he had found on the floor, and we tried it with our plasma ball that we use in one of our cart demonstrations. And it was really, really cool to see that he had taken what we were doing and felt comfortable enough to talk to me, to come up and show me a video from his mother's phone. So back to what I'm trying to research. It's a very small pilot study that I have developed, and it will only look at 2 things for now. It would be so fantastic to be able to do a much more lengthy study, but I'm one person, and it's not a PhD, it's a master's. So right now it's if they touch the object, and if they touch the object, do they talk? So does the talking help with that. And what do they say? Do they just answer questions? I know I did a really, really big crash course, and I only let her answer questions instead of ask them. But it would be really, really, really cool to be able to see what would happen, if it's worth investing in, if it's something that we should be looking into, kind of expanding our what we offer to people. I think that's all I have right now. I know I've talked to a lot of you in person, and I know a lot of you. And a minute and a half?
But altogether 3.5 minutes.
Okay, I would love questions. Yes.
So it's not necessarily about what you brought today.
Okay.
How do you find people interact with Zooniverse?
Oh, you know what? I don't have that much experience with Zooniverse. I know a lot of people do. Do you want to come up?
Do you have particular methods of interaction with Zooniverse?
We just installed we just have it's basically been our museum, and what we did is we are having a Zoomverse kind of theater where it's links up to the website, and we're just going to have our facilitators get people involved in citizen science. Just wondering what you've done and what's been done and what works and what doesn't.
Yeah, we've done similar things. If you know, Zooniverse is a citizen science project. People around the world can via their computer catalog features on Mars, galaxies, black holes, animals, Moon Park Zoo, all sorts of fun things. And we've done that where it's how do you put that out into the floor? In our lobby area outside of our Sky Theater, we actually have Apple TVs hooked up to projectors where the Zooniverse staff can come out on the floor, pull up whichever one of their projects they just launched or whatever one they want to get data on, and actually just run through them on the floor with people.
So they're running them regardless of anybody's staying there in front of them?
No, I mean they'll go up for like an hour or so in the afternoon kind of thing, and just do it with guests at certain times. I couldn't speak to any sort of like logic behind structure of which projects and which times and things like that, but they do that regularly. They participate in a variety of special events, a lot of hack days that we do, things like that.
And there's it's a lot easier to kind of gauge some of the public participation on an online site because you have a lot more data to work with. You don't have someone standing there with a clipboard and a timer. So people are on their own terms and are a little bit more, it's less influenced, I guess. Yes?
I think I speak for Krista as well as myself to say that we learn as much as or more than the visitors do. Doing this UV experiment with a group, somebody asked me a question that sparked a question in my mind. You shine the white light on the rock and it looks gray. You shine the black light on the rock and it looks pink. What color is the rock really? I let them wrestle with that a while, and then I say, the question has no answer. What you see depends on how you look. And that's why astronomers look through the whole electromagnetic spectrum, because every way they look at something shows them something different. The other observation, can you guess what the most common question is that we get?
About the card? Yeah,
Any question.
Where's the bathroom?
Where's the bathroom?
That's what I get.
Where's the bathroom, or where am I supposed to go? And they show you their show ticket, especially with the Johnson Family Theater. Yes. That's a really, really great point. Is every single day you learn something from talking with your visitor. It goes beyond the presentation. It's having the conversation with them, and you learn something new, and you find another way to be excited about what you're teaching. And I was thinking about what I remember most from when I was younger, about museums and about field trips, and I don't remember people very often. I remember people from 2 trips to nature centers, because one was holding a snake, and it pooped on them.
Oh.
And when it comes to the established, stationary institutions where it's in a big building and you have all these really cool things to look at, I definitely remember some of the exhibits, but I don't remember the people. And so the facilitator aspect of it, the person talking to them, would be a really interesting thing to look at too. And that's why my focus was mostly on the CART facilitation, because it was the only opportunity where I could include the physical, the interpersonal, and the exhibits, because the UV cart that we have at Adler incorporates the infrared camera.
Yeah.
And so that's a built-in exhibit, a movable car, and a human facilitator. So it was very nice talking to all of you guys. Does anyone have any other questions? Where's the bathroom? No, it's right around the corner here. Yeah. All right, well, thank you. And thank you for being kind to me for my first conference.
Okay, thank you from the team from Adler. You did a great team job. Okay, now it's Renee Kerrigan's turn. Cross promotion in your dome.
Hi, everyone. Thanks for sticking it out to the last paper of the day. I'm Renee Kerrigan from the Peoria Riverfront Museum. I got this position at the Peoria Riverfront Museum of Planetarium Curator when Sheldon Schaefer retired in January. And I'm talking about cross-promotion in your dome. We just put up this signage this year, and I got a chance to have my face in the dome, and that was going to be the only time ever I got to do that. So I had to use my picture. So in the beginning of this year, our museum's new CEO, Sam Gatmeyer, challenged the museum staff in the programs department to find ways to better connect with whatever major program we have going on at the museum, be it the major special exhibit or a big, program we're doing. He wanted us to connect every space of the museum to that. So he wanted to connect the planetarium programming as well as the giant screen theater programming to what is happening at the museum at the time. And that was an exciting challenge, because, but also quite scary, because in our planetarium we have a staff of 3, and we do not have a budget to buy a full dome show for every new exhibit that we have in a year. We have about 4 major exhibits in a year. So that was our big thing. We had to figure out how to connect with what's happening at the museum with using our existing resources without incurring a greater cost to our department. And our goal was, the point of integrating the museum experience was to try to encourage our visitors who maybe are drawn in by one exhibit to come to the whole space of the museum so that they get a fuller experience, and then they'll be more likely to come back. So we also wanted to be able to create shows and not sacrifice quality to make something just as good as we could purchase. Luckily, we have some great resources. We have our staff of 3, myself, Nick Ray, and Dave Bregner. Many of you know my colleagues. We have our Zeiss ZKP4 star projector in a full dome system. We use SCIS UniView. I'm sure many of you have systems similar that you can fly around the universe in, and that's we have found that to be the most powerful, flexible tool for creating programming quickly about almost any topic. So we use it a lot. And we also, like everybody else in the whole world, have NASA and ESA, which provides us with amazing images and video and data that we can use in our domes to talk about anything we want to. So we began making our own shows again. And I should maybe use the word presentation instead of shows. Lakeview Museum had a long history of this, but we really hadn't put together things on our own since we got our full dome system in 2008. Using our star projector, UniView, or any similar software, and an LCD projector, we found you can make a show about almost anything with almost no added cost, or no added cost at all to your institution. And these shows, by that very nature of being put together quickly by us, are going to be live, which is because we don't want to have to record a soundtrack, but also we have found our audiences respond really well to live shows. So, what did we do? Our first opportunity came when our giant screen theater showed a second-run film of the movie Gravity. that one was pretty easy to connect with in the planetarium. So we created a show called The Reality Behind the Movie Gravity, which is a bit of a clunky title. So sometimes we called it Living in Space. And we didn't want this to be a debunking show. We could have done that. But we wanted people to enjoy it who hadn't necessarily seen the movie. And of course, if they came to the planetarium, we could plug the movie. If they go to the movie, we can plug the planetarium. And it worked out well for both parts of our institution. So we used all of our resources. We always start with a night sky. Then you can talk about how you can see satellites passing above. Then you can use UniView to fly to the International Space Station, show what it looks like as it orbits the Earth. And then we use our LCD projector to use images from NASA and ESA, mostly NASA, I suppose, to show the space station being built and how people live in space. Showed a video with an astronaut explaining how to sleep in space and, of course, use the bathroom, because everybody wants to know. It showed astronauts servicing the Hubble and seeing the Earth from space. It was very well received. Our next big opportunity came with our big blockbuster summer exhibit that we had, which was the Science of Ripley's Believe It or Not from Science North. Not just a freak show like some Ripley's things could be, but they actually explain the science behind the cool things in the exhibit. And so we created the show, The Astonishing Universe, Believe It or Not. This was one of our most popular shows. It was the most popular show of our summer. We do about 5 shows a day, and this show is always the most popular. Did you know Sheldon Schaefer is in a Ripley's cartoon? It says, Sheldon Schaefer of Peoria, Illinois, created a model of the solar system that covers a distance equal to half of the United States. And there's a Sheldon. I'm not sure where they got that picture of you, Sheldon. Are you in here? I don't think he's in here. So we played the cartoons at the beginning. We had, again, starting with our Life's Current Sky, showed where you can find the planets, and then it shared amazing images of these planets that you can get from NASA or ESA. We showed amazing stars you can find in the sky, like Myra, and using UniView, fly out of the solar system, show how far away the stars really are in our constellations, how many galaxies there are in the universe, blow people's minds by going all the way out to the cosmic microwave background, and show how many solar systems there are in our galaxies as well, using the exoplanet fields. One person said that it was the best show he had ever seen in his whole life. Wow. Now, this was the biggest challenge yet, our fall exhibit. How am I supposed to connect in the planetarium to Impressionism into Modernism, a paradigm shift in American art? Now, I love art, so this looked like a really cool show to me, but how am I supposed to do this in the planetarium? So we decided not to focus on the Impressionist part. I mean, we thought about Van Gogh, but instead, paradigm shift. So instead of focusing on a shift in art, focus on a shift in science. And we created a basic cosmology show, the middle of nowhere, talking about humans' shifting understanding of their place in the universe. And for this one, again, we used our major resources, our star projector, UniView, and our LCD projector to talk about a geocentric universe, how the ancient Greeks believed everything moved around the Earth, showed how it looks like that using our star projector, talk about the Copernican system. Then we actually jumped to UniView at that time and talked about Kepler's law, showing the planets actually orbiting in their orbits. You can import your own images into UniView, so we put a bunch of images in there, and then we would fly to the planets as we talked about how Galileo observed them. So go to Venus and talk about show the picture of Galileo's observations, and then talk about how that proved a heliocentric universe. Then shifting to the discovery of our place in the Milky Way, talking about the discoveries of Henrietta Swan-Leavitt, Edwin Hubble, and again, blowing people's minds with the cosmic microwave background. And this is our next opportunity. We're really excited to be showing the first run of Interstellar and the giant screen starting November 7th. We're big geeks. We're pretty excited about it. So we are creating, in fact, I bet Nick is at home working on it right now. Interstellar Voyagers is a show we'll be doing to go along with this. If you go to the giant screen, you can bring your ticket, come for free to see Interstellar Voyagers. We'll be following the motions, or following the orbits of the 5 spacecraft that are destined to become Interstellar Voyagers someday. Pioneer 5 and 6, I believe. Is that right? 10 and 11, Voyager 1 and 2, and New Horizons. Oops, backwards. So, and one of the cool things we'll be able to do is show how science has improved from each of these missions. So, here's Jupiter from Pioneer. It's Jupiter from Voyager. No, it's tiny, but Jupiter from New Horizons. So, following the paths of these spacecraft, showing where they went, and we'll also talk about the Voyager Golden Record and end with the pale blue dot, giving people some cosmic perspective. So the biggest challenge and the greatest strength of these self-made shows or presentations is that they are live. Every single day, they're live shows. And as we all know, to do a great live show, you have to have a great dynamic presenter. And as I said at the beginning, we have a staff of 3, and we do 5 shows a day. They're not all live. But so the biggest challenge has been the staff time that goes into just doing them every day. And you have to know that you can rely on somebody who's really good and will really draw the audience in. But the biggest advantage of these is that they're very interactive. People ask us questions, and in fact, at the beginning, I always say, please ask me questions. I talk fast, so interrupt me. Don't raise your hand. I won't see it. But people feel comfortable enough to ask us questions, and we'll answer them right in the show if we can. Using UniView, we can hand off the controller, and people can pilot the spaceship if it's a good situation for that to happen. And they love that. And we can tailor the show to our audience level, so we can gauge how many young people are in our audience, how many advanced learners are in our audience, and sort of tailor the show to that. And I guess I already said this, but again, the challenge is that we can't really have our interns do these shows or somebody who's less experienced. So we're working on that. And so how did it play in Peoria? Often the show, I don't have hard data to share with you, but I can tell you anecdotally that the show that relates to the big exhibit or the big program we have going on right now is usually the most popular show of the day. And visitors often leave and they comment on being impressed by the presenter's content knowledge, which, I'm not trying to seem like the expert who's super awesome in the front of the room, but I do want to help establish our planetarium as a place people can go to learn about space to a new generation, because I think we've been that before, but you always have to do that as you get more people into your dome. And anecdotally, people come up and tell us they love the shows and that our live shows are really well received. So and I meant to say that if you're interested in any of these show ideas and adapting them to your institution, I did include outlines in the paper that you will get in the proceedings, and I'd be more than happy to share our scripts, as good or as bad as they might be, with you if you send me an email or give me a call. Okay. Any questions?
On the schedule. Okay. Oh. So if there are any questions, you can still entertain a couple.
Yes. How long does it take you to come up with the idea, script it out, and create it in hit play? Or not hit play, but before you open the doors to that show.
She asked how long it takes us to create an idea, script it, and before we start it. It depends on who's making it. So I would say 2 months is good. I mean, we can do it in 2 months. And more time might be better.
Is it one person who does it, or do you guys kind of take?
Nick, Ray, and myself are usually the people. We work together. But one of us will bounce ideas off of each other as well as Dave. And but usually one person creates a profile in UniView or the program in our ZKP4, and then creates a script, or actually not a script, but an outline for the other presenters to go off of. And then also, these shows are adaptable. So I do my show slightly different than my other presenters do, because I have things I'm more excited about than they are. So that's the other cool thing about them. Thanks so much.
That's the end of this paper session.